Hello and welcome to the first video. Today I will be talking about acceleration, velocity, and distance. We will also be going over the relationships, how they're related, and then at the end of the video we'll do a quick practice problem to see if you can apply what you've learned. So let's start off with distance, which can be represented as x or d. And this is usually in units, so it'll always be in units like centimeters, meters, miles, something like feet, something like that. So this is distance. Now we have velocity, which is usually represented as v, and this is usually written as distance over time. So let's say meters a second. And then lastly, we have acceleration, which is usually represented by an A. And this units is usually, so the distance, which is in this case meters per second squared. All right. X, distance, is just plain and simple, how far an object is moved from its original starting point. Velocity is how fast it got there. And then acceleration is the rate of change of the velocity, so how often the velocity is changed. So now we're going to talk about the relationship. So first of all, we have distance. And to get velocity from distance, you take the derivative of x with respect to t, and that gives you the velocity. All right, now that you have the velocity, let's try to get to acceleration. So to get to acceleration, you take the derivative of the velocity with respect to t, and that equals acceleration. And we can go on. I believe the next one would be jerk, but we'll cover that maybe later. All right, so now we see how they're related, except for we can also reverse it. So by taking the integral of a, so with dt would equal velocity. Now if we take the integral of velocity, it would equal the distance. And that's how they're related. So now let's get to work on a practice problem. For our first problem, we have a plane that starts right on a runway. For the first 30 seconds, the plane's acceleration a is given as a function of time, t, by the equation a equals some sort of sign, so there's just a placeholder, and it'll be given a value later in the problem, times t squared, where this is equal to 1 over 90 meters per second to the power of 4. All right. Since we have acceleration, and then at the end, we're t's in seconds, of course, and what is the plane's speed at t equals 30? So to find this velocity, remember that by taking the integral of acceleration, we can get the velocity. So let's get to that. And since this is constant, we can just have it as a constant. So then after we integrate, it would be v equals 1/3. Then the sign over here times t cubed. All right. now that we have everything, we can plug in t. So first of all, we can plug in this into here, and then we'll have to plug in, since we want to know the plane speed at t equals 30 seconds, we'll plug in 30 seconds into t. So 1/3 times 1/90 times 30 cubed. And that ends up equaling 100. However, don't forget your units. Since we're in velocity, it is meters per second. And for this problem, which would be answer C. All right, thank you for watching.